Hello, I'm John, and welcome to this educational video on the history and development of generative AI. Generative AI has transformed the way we interact with technology, enabling machines to create text, images, and even music that rival human creativity. Today, we'll explore the fascinating journey from the early days of artificial intelligence to the advanced generative models like ChatGPT that we use today. Definition of generative AI. Generative AI refers to a class of artificial intelligence systems capable of generating new data such as text, images, or sounds that resemble the training data they were trained on. These systems use advanced algorithms and neural networks to create content that is often indistinguishable from human-created content. Some popular examples include text generation by ChatGPT, image creation by DALL-E, and music composition by AIVA. History of AI development. Early AI concepts. The story of artificial intelligence begins in the 1950s with pioneering work by figures like Alan Turing, who proposed the concept of a machine that could simulate any human intelligence task and introduced the famous Turing test to evaluate a machine's ability to exhibit intelligent behavior. During the 1960s, early AI research led to the development of programs such as ELIZA, which mimicked human conversation, and Shardaloo, which understood and manipulated objects in a virtual world. AI winters. However, the road to advanced AI wasn't always smooth. During the so-called AI winters in the 1970s and 1980s, enthusiasm and funding for AI research waned due to unmet expectations and the limitations of early technologies. These periods were characterized by reduced interest and investment in AI as researchers struggled with the complexity of creating truly intelligent systems. Rise of machine learning and neural networks. Introduction to machine learning. In the 1990s, AI research saw a resurgence with the advent of machine learning, a subset of AI focused on building systems that can learn from data and improve over time. Machine learning introduced new algorithms and statistical methods that allowed computers to find patterns in data and make predictions. Neural networks and deep learning. One of the most significant breakthroughs in AI came with the development of neural networks, which are computational models inspired by the human brain. The concept of deep learning, which involves using large neural networks with many layers, gained traction in the 2010s. Researchers like Geoffrey Hinton, Yann LeCun, and Yoshua Bengio played pivotal roles in advancing deep learning, which led to remarkable improvements in tasks such as image and speech recognition. Generative models. The foundation of generative AI. Introduction to generative models. Generative models are a class of machine learning models that can generate new data samples similar to the data they were trained on. These models have opened up new possibilities in creating realistic content. Early generative models, while promising, had limitations in generating high-quality, coherent data. Generative adversarial networks, GANs. In 2014, Ian Goodfellow and his colleagues introduced generative adversarial networks, GANs, a revolutionary approach to generative modeling. GANs consist of two neural networks, a generator and a discriminator, that are trained together in a competitive process. The generator creates fake data, while the discriminator tries to distinguish between real and fake data. This adversarial training results in the generation of highly realistic content. Variational autoencoders, VAEs. Another important generative model is the variational autoencoder, VAE. VAEs encode data into a compressed, latent space and then decode it back into the original format, allowing for the generation of new, similar data. VAEs have been used in various applications, including image and speech synthesis. Transformers, a game changer. Introduction to Transformers. Transformers, introduced in the landmark paper Attention is All You Need in 2017, revolutionized the field of natural language processing. Unlike previous models, transformers rely on self-attention mechanisms to process input data, enabling them to handle long-range dependencies more effectively. BERT and its impact. In 2018, Google introduced BERT, bidirectional encoder representations from transformers, a model that significantly improved the performance of many NLP tasks. BERT's ability to understand context from both directions of a sentence marked a major advancement in language understanding. The development of GPT models. GPT-1 and GPT-2. The generative pre-trained transformer GPT series developed by OpenAI began with GPT-1 in 2018. GPT-1 demonstrated the power of pre-training on large text corpora, followed by fine-tuning on specific tasks. In 2019, GPT-2 was released, showcasing even greater capabilities with its larger model size and improved performance in generating coherent and contextually relevant text. GPT-3 and ChatGPT. In 2020, OpenAI introduced GPT-3, a model with 175 billion parameters, making it one of the largest and most powerful language models ever created. GPT-3's ability to generate human-like text and perform a wide range of tasks without specific training made it a significant breakthrough. ChatGPT, a variant of GPT-3, is designed for conversational applications, providing more interactive and contextually aware responses. Current state and future of generative AI. Recent developments. Generative AI continues to evolve rapidly with advancements in model training techniques, architectures, and applications. Researchers are focusing on making these models more efficient, reducing biases, and addressing ethical concerns related to AI-generated content. Future directions. The future of generative AI holds exciting possibilities, from enhancing creative processes to solving complex problems in various fields. However, it also presents challenges such as ensuring ethical use, managing the societal impact, and mitigating biases. Ongoing research aims to address these issues and unlock the full potential of generative AI. Conclusion. Summary of key points. In summary, the journey of generative AI has been marked by significant milestones, from early AI research and the rise of machine learning to the development of powerful generative models like GANs, VAEs, and transformers. The evolution of GPT models, particularly GPT-3 and ChatGPT, has showcased the immense potential of generative AI in transforming how we interact with technology. Closing thoughts. As we look to the future, generative AI will continue to shape various industries and aspects of our daily lives. By understanding its history and development, we can better appreciate the incredible advancements that have brought us to where we are today and anticipate the innovations yet to come. Thank you for joining us on this journey through the history and development of generative AI.